The Andromeda system has revealed to humanity that our universe is not centered around us. This realization confirms that Earth is not the only place with a galaxy, suggesting that we might be just a small part of something much larger. Over the last century, our understanding of Andromeda has expanded, largely due to observations made from Earth. However, with advanced tools like the James Webb Space Telescope, our knowledge has significantly evolved, uncovering surprising new details about Andromeda. Just over 100 years ago, people viewed the Milky Way as a faint band of light in the night sky, unable to discern individual stars due to the limited technology of the time. Some even believed the Milky Way was the center of creation, where heaven and earth met. In the early 17th century, Galileo Galilei changed this perception using his telescope, revealing that the Milky Way was composed of countless stars and celestial bodies, not just a hazy light. This discovery demonstrated that Earth was not the center of everything but part of a vast universe. In the 1750s, Thomas Wright proposed that the Milky Way was not just a random scattering of stars but rather a flat layer of them. He even suggested that our solar system was part of this structure. While this was an important advancement, it was still constrained by the technology of the time. By the mid-19th century, astronomy was progressing rapidly. Edwin Hubble's groundbreaking observations with a 100-inch telescope in the 1920s revealed that nebulae beyond the Milky Way were actually separate galaxies, each containing billions of stars. One of these galaxies was Andromeda, also known as M31. The history of Andromeda dates back centuries, with records from the 10th century by Persian astronomer Abd al-Rahman al-Sufi, who described it as a small cloud visible to the naked eye. Andromeda is unique in that it is one of the few galaxies visible without a telescope, appearing as a faint cloud in the sky. In the 17th century, enhanced observations provided more detail, setting the stage for future studies. French astronomer Charles Messier catalogued Andromeda as M31 in 1764, though he mistakenly credited its discovery. Nevertheless, his work placed Andromeda on the map, sparking global interest. In 1864, British astronomer William Huggins made significant strides in understanding Andromeda. His groundbreaking spectroscopic analysis revealed differences between Andromeda and typical nebulae, offering new insights into its true nature. Today, Andromeda is recognized as a colossal galaxy, roughly 1 to 2 trillion times more massive than our Milky Way. It is an ancient giant, estimated to be around 10 billion years old, with theories suggesting that it formed through the merging of several smaller proto-galaxies over billions of years, a common process in the universe that shapes the development and structure of galaxies. For much of the 20th century, astronomers believed that Andromeda was much larger than the Milky Way. However, recent research has led to a re-evaluation of this idea. It turns out that the two galaxies are much closer in size than previously thought. Andromeda's true size is impressive, with a diameter of about 220,000 light-years, extending farther than the Milky Way. This new understanding highlights the complexities of measuring galaxy mass, which is intricately linked to the distribution and movement of stars, gas, dust, and dark matter within them. One of the most fascinating aspects of the Andromeda Galaxy is its active galactic core. This vibrant region at the center of the galaxy is powered by a supermassive black hole. Observations have revealed an intriguing feature. The core seems to have two distinct centers of activity, with intense emissions occurring in two separate areas. Supermassive black holes are common at the centers of galaxies, including our own, and play a crucial role in their growth and dynamics. When matter, such as gas and stars, gets too close to these black holes, it forms an accretion disk, which heats up and produces immense radiation across various frequencies, making the active galactic core incredibly bright. Studies of Andromeda's core have revealed that its central black hole exerts a tremendous gravitational pull on surrounding stars, causing them to orbit it in elliptical paths. The area closest to the black hole experiences the strongest gravitational forces, causing stars to move at extremely high speeds and accumulate around the black hole. This congregation of stars releases energy as radiation, contributing to the observed brightness of the central region. These observations provide valuable insights into gravitational interactions and the dynamics of galaxy cores. Andromeda is also home to an abundance of globular clusters, dense groups of stars orbiting its center. With around 460 of these clusters, each containing thousands to millions of stars, Andromeda's globular clusters offer important clues about its history and interactions with smaller galaxies. The formation of these clusters and stars through a process known as galactic cannibalism has enriched Andromeda's stellar population. Recent observations suggest that Andromeda may be transitioning from a typical spiral galaxy to a more unusual ring galaxy. Ring galaxies are characterized by circular or arc-like structures containing young blue stars, while their central regions have relatively little luminous matter. This transformation adds to the fascination surrounding Andromeda's evolution and highlights the dynamic nature of galaxies in the universe. Ring galaxies, on the other hand, have off-center cores, and their rings tend to be more irregular. These rare galactic structures, found in only about 1 in 10,000 galaxies, are thought to form through cosmic collisions, such as the merging of two galaxies or when a smaller galaxy passes through the center of a larger one, triggering the formation of a ring-like structure. Notable examples of ring galaxies formed by cosmic collisions include the Cartwheel Galaxy, PGC 2248, and ARP 147, which showcase the complexities of astronomical events. What's happening in Andromeda now is even more exciting. Scientists predict that the Milky Way and Andromeda are on a collision course and will eventually merge to form a new, supersized galaxy. This monumental event, which has been dubbed Milkomeda, will have profound consequences for both galaxies, particularly for Earth. As the two galaxies approach each other, their massive gravitational forces will distort each other's shapes, leading to tidal interactions where stars, gas, and dust are pulled between them. This process will cause chaos and destruction as the galaxies begin to overlap, but the merger will not occur overnight. The collision will take place over billions of years, during which the galaxies will undergo dramatic changes. The process will cause stars, gas clouds, and dust from both galaxies to merge, leading to the formation of a new galaxy. While the exact outcome for Earth remains uncertain, it's clear that this cosmic collision will mark a pivotal moment in the history of our universe. The development of new star clusters and structures within the recently merged universe will be driven by the massive black holes at the centers of both galaxies, which will eventually merge to form an even larger black hole at the core of the newly formed system. This merging process can trigger bursts of star formation, leading to the creation of star clusters, shock waves, and brilliant radiation eruptions, dramatically changing the night sky as new stellar groupings and cosmic structures emerge. However, while these cosmic events unfold on a grand scale, their effects could ripple down to planetary systems, disrupting Earth's environment and climate. Changes in temperature, precipitation, and weather patterns may occur globally, impacting the distribution of plant and animal species. The altered climate could affect processes like photosynthesis and other essential life-supporting cycles, potentially causing disruptions in ecosystems and threatening the survival of various species. Moreover, these changes could interfere with migration patterns and reproductive habits of animals, leading to difficulties in finding food, water, and suitable breeding grounds. Increased competition for resources could reshape biodiversity, with some species thriving in the new conditions while others struggle to survive, ultimately transforming the balance of life on Earth. Unfortunately, some species may not be able to adapt quickly enough, leading to localized extinctions and further disturbances in habitats and migration patterns. These disruptions could have cascading effects throughout entire ecosystems, possibly resulting in the loss of certain species from specific regions or habitats. While these dramatic cosmic events may seem inevitable, the actual collision of the two galaxies will not occur overnight. The impact is projected to begin roughly 4 billion years from now, and the entire merging process will take another 2 billion years to complete. As for our species, by that time humans will be long gone, and Earth will have undergone profound changes long before the galaxies even begin to collide. Around 5 billion years from now, the Sun is expected to expand into a red giant, likely engulfing the inner planets, including Earth. This process will probably make our solar system uninhabitable well before the merger of the two galaxies takes place. If any descendants of our species or other forms of life still exist 4 to 6 billion years from now, They will be vastly different from us in terms of evolutionary history. The fate of our planetary system in the new supergalaxy is uncertain. It's possible that our solar system could be ejected into the intergalactic medium during the collision. However, the precise outcome and structure of the new galaxy are difficult to predict with certainty. One possible outcome is that the galactic disks of the two galaxies will be disturbed, and the spiral arms of each galaxy will be scattered. Whether this results in a new elliptical galaxy, a giant disordered system, or a hybrid structure is something we won't know until the merger actually happens. As the Milky Way and Andromeda galaxies merge, the immense forces and interactions between stars, gas, and dust will form a new cosmic structure distinct from what we've known. Within this newly formed galaxy, star systems with planets may exist within habitable zones, where conditions could be suitable for liquid water. Liquid water is considered essential for the development and sustenance of life as we know it. However, the stability of this new galactic structure will be crucial in determining whether life can thrive there. Gravitational interactions between stars and potential disturbances could affect the orbits of planets and environmental conditions, influencing the development and sustainability of life on any potential habitable planets. The merger could also lead to increased astronomical radiation and cosmic events like supernovae and gamma-ray bursts. The actual occurrence of these events and their influence on planetary environments are difficult to predict. If life were to arise in the new galaxy, it would likely undergo evolution based on the specific conditions of its environment. The unique physical and chemical properties of the new galactic region could give rise to life forms unlike those we know on Earth. The merger of the Milky Way and Andromeda galaxies marks a cosmic spectacle unfolding on an unimaginable scale, reshaping our understanding of galactic evolution. As these two massive entities move toward each other over billions of years, their gravitational dance will not only alter their physical structures but also produce significant galactic phenomena. One likely result of this cosmic collision is the formation of a new supergalaxy, a hybrid entity created by the merger of billions of stars, gas clouds, and dark matter halos. This merging process will trigger a cascade of events, including the bending of both galaxies' spiral arms and the eventual fusion of their stellar populations. Massive black holes at the centers of both galaxies will coalesce, releasing vast amounts of energy into the surrounding space. The collision will send shockwaves through the interstellar medium, igniting intense bursts of star formation as gas and dust clouds collide and collapse under gravitational forces. The new stars born in the aftermath of the merger will light up the night sky with their brilliance, creating spectacular cosmic displays visible across vast distances. However, amid this astronomical spectacle, there is potential for disruption on a planetary scale. As the galaxies merge, gravitational interactions could destabilize the orbits of planets, leading to changes in temperature, radiation levels, and atmospheric composition, presenting challenges for any existing life and potentially altering the habitability of nearby celestial bodies. The resulting structure of the new supergalaxy will leave a lasting mark on its morphology and dynamics. The intricate interactions between gravitational forces and stellar processes will determine whether the new galaxy adopts the form of an elliptical galaxy, a twisted spiral, or a hybrid structure combining elements of both. For astronomers and cosmologists, the merger of the Milky Way and Andromeda offers a unique opportunity to study the large-scale evolution of galaxies. Advanced telescopes and computational models will enable scientists to observe and simulate the merging process, providing insights into the fundamental processes that govern the formation and evolution of galaxies across the universe. Furthermore, the merger offers broader implications for our understanding of cosmic evolution, illustrating the dynamic nature of galaxies as they interact, merge, and evolve over vast timescales. It underscores the interconnectedness of celestial bodies within the universe, highlighting the ever-changing nature of the cosmos. The merger of the Milky Way and Andromeda represents a pivotal moment in cosmic history, showcasing the interplay between galactic phenomena and their potential impact on the fate of planetary systems within their reach. As researchers continue to unravel the mysteries of cosmic mergers, humanity's understanding of the universe's past, present, and future will continue to grow, driven by curiosity and the pursuit of knowledge at the farthest frontiers of space.